For GATE Aerospace aspirants, we have started the series of Question of the Day and Concept of the Day, which we are posting on our official YouTube and Telegram channel. As we know that in GATE exam, most of the question will be application-based question, right? So it's not about knowing the concept. It's all about how well you're applying those concepts in the question, right? So this is going to help you to build your conceptual ability. So for example, this is a question from strength of material, torsion topic. We have to find out maximum value of the torque acting on any section. Similarly, next example is again from structure, that is truss topic. We have to find out the force in the member CB, right? This we can find out by taking the equilibrium of the force in horizontal and vertical direction at any point. Next is from fluid mechanics, where velocity component U, V, W are given, and they are asking about possibility of the flow and rotational or irrotational flow, right? To check the possibility, we can apply continuity equation. To check whether it is rotational or irrotational, we can apply condition of irrotationality, that is curl of velocity vector is equal to 0. If it is coming equal to 0, flow will be irrotational, right? Next example is from gas dynamics. Topic is moving normal shock. So both air and shock are approaching each other. So here we can apply the relative velocity concept, which we have discussed in the lecture, and then we can find out delta P across the shock, right? So this was from gas dynamics, moving normal shock. Now about the concept of the day. So this in all three cases, frequency of the vibration is same. So we know that for simple spring mass system, whether it vibrates like this or like this or like this on inclined surface, frequency of the vibration will be same. And detailed region we have already seen in the lecture. You can quickly go through with key points here. Next is about the response of this system. So for example, undamped system where zeta is equal to 0, right? It is pure oscillatory, shown in green curve, where amplitude remains same. Second, underdamped, zeta is less than 1, right? Shown in red. Here amplitude is decreasing, right? This sky blue curve shows critically damped system with zeta is equal to 1. It is returning to the equilibrium position in minimum possible time, so it is critically damped. So you can quickly go through with the response of all the system, right, by looking at this graph. Next is about displacement compatibility. So this is a cantilever carrying uniformly distributed load, and it is having support here at the tip, right? So we know that deflection at this point, point B, will be 0, right? So the downward deflection due to the uniformly distributed load W will be equal to the upward deflection due to reaction force RB alone. By equating both, we can develop the relationship, and by using this relation, we can find out this unknown RB, which we could not find out by using the law of static alone, right? Similarly, we can develop the relationship for this cantilever carrying uniformly distributed load and with spring support, right? So links of all the social media channels are given in the description. You can join those channels and stay updated.